a copy of the proceedings after the fact.
I think you need to talk here, that is recorded with the microphone.
Okay. Hello. Okay. Morning. My name is Johan Wichter. I represent Pergam Technical Services. Along with that, I'd like to introduce Peter Mantel here from Distrand, Switzerland, from the manufacturing side of the product. We cover and support North America for what we're going to be talking about this morning, which is this unit here. It is a multi-gas acoustic leak detector, self-calibrating with real-time quantification of all gases. Along with that, it identifies electrical issues, it sees vacuum, and so on, and we'll kind of go through these items as we progress for the next 30 minutes or so. We have a booth here at the show. I have a background in NDT myself on the nuclear side. We've been supporting the oil and gas and refining community since about 2006. And we're going to be speaking more in detail about the camera, its capabilities, and the details related to that. So, important today, and it has become a real topic over the last few years. Not to say that it wasn't a topic before, but we're talking about environmental protection, we're talking about safety, we're talking about emissions, and we're talking about quantification of gas. I have a background in methane myself. The ability to go from ppm, to go from LEL and percent gas to into a quantification situation has entirely changed the way that the industry has accepted volumetric quantification real time. This camera, within tens of seconds, has the ability to focus on the largest leak in the environment and quantify it for you. Why? Because it's not gas specific, it operates off pressure. Okay, and we're going to go through that here shortly. So, what we're talking about here is real-time visualization of gas, regardless of gas, including hydrogen and nitrogen that are very complicated for other platforms to see, specifically OGI. And here's what I'm talking about. The ability to identify and quantify. This is your deliverable on the user interface of the camera, and it's immediate. You have the ability to store video along with high definition stills of this environment, which means that by the time that you get back from having conducted your inspection, you have a very valuable deliverable stored on a standard size SD card in the base of the camera. Here, we are showing you the distance at which you can capture information, store information. We note that autofocus, which is a feature of the camera, is visible to you, and this is real. Lower left, we have the minimum threshold. In the middle here, to give you perspective, we have the actual. That is the actual given distance and pressure and gas and so on that we capture and we provide and we can share, okay? So this is a passive technology that operates between 8 to 60 kilohertz, which means that within this frequency range, we can see all the things that we've just talked about, where the generic frequency on the instrument is 31, okay? 31 kilohertz. So the way it works is that we have a difference in pressure between the inside of the pipe and the outside of the pipe, the ambient pressure. The gas leaks out. Keep in mind, this camera here is designed for pinhole leaks. It is not designed for your average mundane larger leaks. We will see those too. But it is designed down to 0.7 psi pressure. The ability to see that along with vacuum and everything else I've just touched on creates what we refer to as a vortex. Atmospheric pressure being lower creates a leak. We hear this, where the generic catch frequency, again, is 31 kilohertz. Field of sound, 180 degrees. Field of view, 110 degrees on this 2.9 pound camera. So, we talked about the ultrasound, we talked about the deliverable. Real time, minimum threshold. Autofocus means in this case that the camera is doing the work for you until you get really granular with the menu. We have a menu that is a touch screen menu. And that gives you the ability to go deeper into the granularity of the camera. So we are talking about ultrasound passively coming to you. The camera processes a signal. It overlays a visual on the user interface. The user interface, and I can show you this after the fact that at our booth as well, shows you with immediacy what we're talking about here. Standard cubic feet per hour and your ability to capture data and walking away with data. So I guess what I'm trying to say here is that relative to valuable gases, you are able to monetize this experience, and you can extrapolate that loss into a 24-hour situation, by month, by year, giving yourself a data point as to how much you're losing. So pinpointing, talked about that. Here you can see the operator walking around with the camera and the neck strap. So it is immediate. You can see that the ability to capture is real time. We captured that with video, real, minimum threshold. Here are the settings, the distance to the area of investigation, and we see multiple gases because we are pressure specific, we are not gas specific. So, what needs to happen? So, we are looking at a minimum 50 bar, 7 psi detection capability. And while the camera is designed for 100 feet or 30 meters of capability, the average inspection distance is upwards of 13, 14 feet, that sort of thing, removing the need to climb anywhere or get into a situation that is not safe, okay? We've talked about pinpointing. There are a couple of things that the camera cannot do because it operates off pressure, and that is no underground buried pipe, subsurface situations, or insulated pipes. Now, insulated pipes means that if the insulation is sufficient enough and good enough and new enough, we're not going to see anything. But in the event that the insulation is not new, been around a while. I have, in my experience, noticed leaks on either side of where the insulation may be a little deteriorated, if you will. So we're looking at about 3 pounds for this camera here. It is a single hand situation. Minimum flow rate, 0.1, pressure 0.7 PSI, talked about that. 2 versions, intrinsic, non-intrinsic, which means that we have both versions as being the first manufacturer of an acoustic, an ultrasonic capable camera that is multi-gas, having an intrinsic version as required. And the typical environments, as I said, is really from 3 to 20. I said 14, so I'm right in the middle there somewhere. But the camera is designed for 30 meters or 100 feet capable. So there is a feature on the camera, just to get into a little bit on the menu here. It's a unique feature that involves autofocus, AF. AF is displayed on the user interface down in this corner. Along with that, we also have manual focus. When you're starting out with the camera, most operators, most users, before they get comfortable with the camera, which really doesn't take very long, use autofocus. As you get better at working the surveys, then you will switch to a manual focus that involves a change in distance, and it involves a change in pressure as you understand, as you know what the pressure is in the pipe. You will change that correspondingly. But initially, most people start out with an autofocus, with an autofocus, and then transition to manual focus. Because what happens is sometimes the leaks are so small that you have to be patient, transition properly, and this is where the different distances on the user interface and the menu structure come into play and become relevant. So here's the video playing where you can actually see this. So all these little reflections around are echoes. They are echoes off the main leak. And while it is hard to see, we are still able to capture it. Why? Because we have transitioned from auto to manual. And once again, that is the minimum, and then the actual is always displayed in the center of the camera from a practical standpoint. So autofocus is really, it's an automatic adjustment where I said before the camera does the work for you, okay? This is where you're starting out with perhaps 31 kilohertz, and you have the generic focus, all the details being worked through the camera. And here is the video pertaining to that situation. You can see that we are real-time adjusting for distance and quantification, real-time quantification. So as opposed to where we had manual here before, we now have auto, okay? And we have a distance that's real. So so as you're walking through the plant, as you are walking through the plant with this camera, the camera consistently in front of you has 180 degrees. Now, you don't know this yet, but the camera, along the user interface will guide you to your next leak. So you will actually see coloring on either side or above that will guide you to your next leak. That's how the camera works. So while I am saying it takes a little while to get used to, it really does. I would venture to say that within 30 minutes or less, having started up this self-calibrating, multi-gas, real-time quantifying camera, where the data is stored in here, the SD card that you can pull out, you have a real good understanding of an environment that took perhaps much longer before to inspect in far shorter time. So while we were out in Baton Rouge last week, we walked multiple locations in a far shorter time with a group that had never experienced this before, and the revelations. I don't want to go out on a limb here, but they were quite profound. Just to get a little sort of data. This little button here stores the data in the video. This is what you use. So we talked about autofocus, we've talked about manual, and I've touched multiple times on the live leak, which is the real-time quantification regardless of gas. We don't care what the gas is: nitrogen, hydrogen, CO2, air, methane. It doesn't matter to us. We calculate it, we display it, we show it, we capture it. This is what we do. Why? To assess volume, to limit emissions, and to eventually evaluate losses that we can monetize, as I touched on before. So all this is real today. And here's the video that shows you that experience. So you can see in the middle we have the real definition, and then we have the minimum threshold. We talked about that before on the lower left. And in this presentation, again, here we have autofocus, camera doing the work, processing the data, capturing the data, storing the data, and that's the distance to the area of investigation. So here is a very, very traditional standard methane leak. Really nothing special, but this is what you see when you walk out. When the camera is calibrated and it is turned on and you walk out, this is what we see literally within seconds. We capture it and we store it, and we can go to multiple locations at a far faster clip than ever before. We have the frequency up in the upper left-hand corner, and we have the auto survey, which is the distance to the area there. Really. The SD card itself, the one that we have here, I believe is 8 gig, stores about 14,000 images, hundreds of images. Battery on this camera, we have 2 in the box, are 2 3-hour batteries. We have a 1x zoom on the camera. You can see here that we're capturing about 800 and 900 liters per hour real time. And we have the ability to go 1x granular on the leak. And of course, that can be stored on the SD card as well, which is the real data that you're looking for. So minimum, real, autofocus, 2.4 meters, short of 10 feet. Hydrogen capable camera. So here you can see once again a real visual of what we see and what we capture with a camera that is gas agnostic, multi-gas, relative to other platforms that are currently used traditionally in the industry. second video playing right there. So you can see that what we're showing you here is not something that is a product that just came out. This has been around since its early days of 2011. And I think it was in 2021, Peter, that the intrinsic version came out, right? Yeah, the ATEX version came out. So we have supported this since 2019, starting here at 4C, I believe it was actually. And the adoption, the level of interest has been pretty phenomenal. It wouldn't be phenomenal if we just had an LEL or percent gas or some other type of unit of measurement. We have something that we display. We have something that we capture. We have something we can monetize. We have something that we can bring back home and we can share the information. The camera itself has its own IP address, okay? So all the software upgrades, all the firmware upgrades, all of these things come through the internet. So there's no need for you to ever send this camera back anywhere, where the new gases and the new modules and everything pertaining to the camera can be taken care of through the internet. So there is no need to send it back to the factory anymore. So that is a real step forward. Steam, not that complicated, but this is what it looks like from give or take 60 feet away. Compressed air. What this is all about is the ability from 30, 40 yards away to walk into an environment that is loud, dirty, complicated, windy, and detect a leak like that from the distance on the far left. So in the event that you're interested, I can send you the video so you can actually see for yourself how the inspector migrates over. He walks out actually and then scans the landscape, turns the camera to the left and sees that at a distance, then eventually walks over and identifies that. So while I don't want to come across as knowing everything about leak detection or knowing every platform on the planet, the ability to detect at a distance, multi-location, multi-gas is very, very new. Vacuum leaks. We have the ability to find vacuum leaks. This is a sample of that. I can tell you that the International Space Station has one of these units. Vacuum leaks. So we're not only talking gas, we're talking vacuum, talking lower voltage electrical substation, anywhere. It's not just gas. We focus on power. We focus on all of these gas intensive applications. However, we have the ability to go beyond that, much more beyond that, which is why vacuum is a real key to us. And here's the video that shows you the display of vacuum capture. You can see that right there. So what we do is, as you know by now, we inspect, that is, we inspect, we capture, we store data, we capture data, we quantify data, and we have the ability to share data. I talked about the SD card that's on the camera here. We can also upload the information through the internet. As we said here, each camera has its own IP address. So in the menu structure, you have the ability to go in and deactivate the camera, it's called, but really what you're doing is preparing it, upload the picture automatically into a portal for which you have a log on. One log on per camera. Each camera comes with a portal. And so that information there then is automatically stored. So we document, we repair. The ability to share the information is very real. Time and time again, we hear that there's no more number 2 pencil, there's no paper involved. Take a picture of the asset tag or the VIN number or whatever the location may be for traceability. And so traceability is very key. Fast, obviously, we talked about that. And it's a very collaborative effort because the information can be shared internally at rocket speed. So we've talked about 2 different platforms here. What I am saying here is not detrimental to FLIR. FLIR is a tremendous product. It is a world-class company. What I am saying is that we have taken it a step further. So we now have the ability to real-time quantify. Holding this in your hand, we complement FLIR. We take it a step further because this data is more immediate, it's more shareable, it's more uploadable, and I believe that in combination with the 2, there are platforms that are very conducive to mitigating emissions. So we talked about this, the capabilities and the speed and the safety are very similar. However, the acoustic unit is far faster. And we have an ATEX version. We can real time, regardless of wind. Wind beyond 30 miles per hour obviously is not conducive to what we're talking about here. But if you're looking at 10, 15, 17 mile per hour winds, you will be able to see. Guess what? We are operating off pressure. We're not operating off an optical gas imaging platform here. By the way, I'd like to reiterate that FLIR is a world-class company, but we've taken it a step further. So here is generally speaking, just a short overview for you regarding the differences and the similarities between acoustic and the OGI and so on. And you can see that we have, you're familiar with OGI, we have a plume presence there, a visualization, and then we have indication on and real-time quantification and so on with the what I might say here is on the left-hand side, you're seeing the OGI EPA recognition. So I'm going to go out on a limb here a little bit and tell all of you that the EPA is in the process of evaluating the Ultra Pro here for the same type of certification that the FLIR camera has been enjoying for quite some time. So that is in the process of happening. And that started last year, by the way. So. And while this is generally a deliverable or a technical overview, we're going to be here at the show. So if you're interested in understanding the expense structure of acoustic versus OGI, we'd be glad to share that with you at our booth. So in conclusion here, We have 2 deliverables for the same indication. Acoustic, pinpoint, and we have optical gas imaging. Both are good technologies. We've taken it a step further, and that is visible to us. So specific applications, we talked about nitrogen and commissioning. We talked about being able to document where you've been and what you've seen. And here's a very typical meter set somewhere in the United States that gives you the ability to identify. And you've got your VIN tag there, your VIN number that tells you the meter set, building specific information. And much of the industry has adopted the platform. And I didn't make that up. It is on the space station. My question to this group is, if you had vacuum leaks on the space station, would you go up? But this is where it's at. So, and I think this was 2021 to 2020, maybe it was. It's been out there for about 2 years, give or take, that environment. So in conclusion, I'd like to just thank you for your time. And Peter and I are going to be at the show here. If you have any questions, I've got some cards here. Feel free to contact me, and I'd be happy to take just questions perhaps you might have. So thank you.